typical Delco maintenance-free Freedom batteries represent a major technological advancement in heavy-duty battery design. The maintenance-free battery is similar to the old-style battery in one respect. They both are lead-acid type batteries. The electrochemical reactions are therefore essentially the same. However, the degree to which these reactions occur is different. Let's see why this is so by looking now at some of the design features of the heavy-duty maintenance-free battery. One of the most important design features is the grid, which holds the plate material. A patented process is used to make a grid containing lead-calcium alloy. The antimony has been completely eliminated from the grid. The result? Water usage and gassing are reduced to a very small amount throughout the lifetime of the battery. This patented process produces a wrought, work-hardened lead-calcium grid that is strong and has a fine-grained structure. Wrought lead-calcium is very resistant to oxidation of the grid, often called grid corrosion. This type of corrosion occurs mostly at high temperatures. Since corrosion weakens the grid, this major cause of failure has been almost eliminated in the maintenance-free batteries. The self-discharge rate of the lead-calcium battery is very low. This means that a maintenance-free battery can be placed in service after having been stored for over 1 full year. By contrast, the old-style battery could only be stored for 4 months or less without periodic boosting. To illustrate this improvement another way, the maintenance-free battery can be stored for over 1 full year without periodic charging, whereas the old-style battery would have to be charged frequently. The maintenance-free battery is also highly resistant to overcharge or thermal runaway. This high resistance to thermal runaway results from the removal of antimony from the grid. A fully charged lead-antimony battery may accept 10 times as much overcharge current as a fully charged maintenance-free battery. This thermal runaway will cause permanent plate damage and shortened battery life on the old-style battery. To summarize, the maintenance-free battery with its wrought lead-calcium grids that are completely free of antimony offers high resistance to the following undesirable characteristics. 1. Water usage. 2. Grid corrosion. 3. Gassing. 4. Self-discharge. 5. Thermal runaway. At this time, we'll look at some of the other design features of the maintenance-free battery. The case of the Delco heavy-duty Freedom battery is made of polypropylene. It has the advantage of lighter weight and improved cold weather durability as compared to hard rubber cases. This polypropylene case can also easily withstand road shock and vibration. In any element, alternating plates are placed inside an envelope. These envelopes take the place of the separators, and they help prevent treeing and shorting between the plates. These envelopes, made of a high-quality microporous material, are sealed on 3 sides to prevent treeing and shorting on the edges. A stronger resistance to grid movement due to vibration is accomplished as compared to the old-style lead-antimony grid. The grid straps have been located near the center of the grid to reduce their lever action due to road shock. In addition, with the envelope separator, no sediment chamber is required, so plates are placed on the bottom of the case. Epoxy is added to prevent movement. With the plates installed into the case, a special liquid gas separator is heat sealed to the case, and a cover is heat sealed to the liquid gas separator. This liquid gas separator is designed to collect very small particles of electrolyte liquid, a feature which prevents electrolyte losses by collecting and returning the liquid to the main electrolyte reservoir of the battery. As we have seen, gassing is practically eliminated in the maintenance-free battery. However, to allow for expansion and contraction of the electrolyte during charging and temperature changes, A small vent is built into the side of the liquid gas separator. This vent allows the small amount of gases that are produced over the lifetime of the battery to escape. The vent is protected with a flame arrestor to minimize the chance of an explosion during charging. The stud terminals of the Delco heavy-duty Freedom batteries are for the sole purpose of providing a sealed electrical connection with the mating cable. As shown, a sealed cable termination is held in place with a stainless steel nut. Since there are no filler caps present, corrosion from escaping gases is eliminated. However, by sealing the electrical connection, corrosion caused by road salt, dirt, and other chemicals is also eliminated. As an aid to the mechanic, a simple hydrometer device has been placed in one cell. This device consists of a small green-colored ball within a cage fastened to the end of a plastic probe, which can float up or down within one of two small tracks. If the electrolyte is at or above a specific gravity of 1220, the ball will float, and thus the observer will see a green dot when looking down on the built-in hydrometer. This tells him no charging of the battery is required. If the specific gravity is less than 1220, the ball will sink down one of the two tracks in the cage, and the observer will see only a dark surface. The ball itself expands and contracts for temperature compensation. The dark surface means that before testing, the battery must be charged until the green ball floats. Only one indicator in one cell is required. Since the top is sealed, there is no chance for electrolyte in each cell to be either overfilled, underfilled, or contaminated. So the specific gravity of each cell will be almost identical. Should the battery be severely overcharged or tipped over, the hydrometer may become clear or light yellow, indicating low electrolyte. If a cracking problem exists, replace the battery. Do not test or charge. To summarize, the built-in hydrometer is an aid to the mechanic when there is a cracking problem. Otherwise, it can be ignored. As you can see, the construction of the heavy-duty Freedom batteries has been designed to take the maintenance out of the battery service life. The discharge characteristics of the Delco heavy-duty Freedom batteries are no different than an old-style battery of the same cold cranking ampere and reserve capacity ratings. The charging characteristics are slightly different, however. Using an ordinary battery charger, both a Delco Freedom battery and a lead antimony battery will accept the same rate when at the same state of discharge. As both batteries approach about 90% state of charge, the Delco Freedom battery begins to accept a lower current than the lead antimony battery. During this portion of the charging, most of the gassing will occur. Consequently, as the current acceptance drops off, there will be far less gassing in the Freedom battery. If the voltage is kept constant, approximately 14 volts, the charging current will be less than 1 amp in the Delco Freedom battery. Less gassing not only results in lower water loss, but also reduces the harmful effects of grid corrosion, thus provides longer battery service life. When the green dot is visible, it does not necessarily mean that the battery is fully charged, but that it is charged enough to be tested. As long as the green dot is visible, the battery can be put into service. Normal service operation with a suitable charging system will keep the battery up. If the green dot is not showing, charge the battery at any initial rate up to 50 amperes. Set the timer, if available, to no more than 1 to 2 hours to prevent spewing of electrolyte. Stop charging when the green dot appears. Slow chargers can be used provided the battery is checked regularly for spewing of electrolyte and for excessive warmth, over 125 degrees Fahrenheit. When using a slow charger, it may be necessary to shake up or tilt the battery to mix electrolyte so that the green ball can float. Then stop charging when the green dot appears. Another consideration is boost charging. Batteries which have been run down by repeated cranking can be boost charged sufficiently to crank the engine. But remember that boost charging will not fully charge a battery. Follow the manufacturer's instructions when boost charging. Be sure to connect positive to positive and negative to negative to prevent damage to charger or battery. Batteries which have run down due to lights or other circuits being left on will require a longer charge time. Maintenance-free batteries discharged to this extent may at first appear to not accept current, but after several minutes, noticeable current will be detected. This current increases as the electrolyte becomes more conductive. In time, the charging current will peak and then decrease as the battery becomes charged. Charging times of several hours will be required to obtain the green dot indication. The self-discharge of the Delco Freedom battery is so small that even after 1 year of storage at 80 degrees Fahrenheit average temperature, the battery has enough power left to crank the engine. Even though the maintenance-free batteries have flame arresters, caution should be exercised to prevent igniting the escaping gases, which are highly explosive. For additional information regarding safety precautions and charging, refer to Delco Remy Service Bulletin 1B-116. The failure modes of the maintenance-free Freedom batteries are similar to the lead antimony batteries. However, as discussed in Part 1, the lead antimony battery loses excessive water and active material and suffers grid corrosion due to excessive gassing during overcharge. The Delco Freedom batteries resist these harmful effects, but eventually will also fail if overcharging continues. Therefore, the same charging precautions should be followed. Reduce the rate if the battery exceeds 125 degrees Fahrenheit, feels warm to the touch, or if electrolyte spewing occurs. To summarize, the Delco maintenance-free heavy-duty batteries, through advanced design features, offer a greater resistance to the following typical battery problems: plate shorting or treeing, road shock and vibration, electrolyte spillage, leaking, overfilling, underfilling, and contamination, improper activation, hydrometer damage, terminal corrosion, explosion. Now that the features of the heavy-duty Freedom batteries have been discussed, let's look at some factors to consider when selecting a heavy-duty Freedom battery. The Delco 1200 was designed to provide many thousands of miles of over-the-road service life. So, in addition to the features already discussed, the number of plates per battery was carefully selected to minimize water loss during its service life, and also to obtain all the advantages of a 4-battery system, as discussed in our CCC Practice 106. A Delco 1200 4-battery system with sealed terminals and properly specified Delco Remy heavy-duty cranking motor and alternator provides the fleet with an electrical system that is virtually trouble-free. However, in certain applications, a 4-battery system cannot be installed. If the CCA requirement cannot be met with fewer than 4 Delco 1200s, then 3 Delco 1110s are required. The Delco 1110 has identical features to the Delco 1200, except that it has more plates and a higher CCA rating for more cranking capacity. More plates in the same size case will give more cranking capacity, but does result in less electrolyte reserve. In addition, when fewer than 4 batteries are used on large engine applications, the advantage of a 4-battery system, as described in our CCC Practice 106, is reduced. Another special applications battery is available when frequent starting is required, or when high electrical loads occasionally exceed the alternator output. The high-cycle Delco 1150 battery. With its higher density plates, The Delco 1150 provides the reserve capacity needed to carry these vehicle loads and still provide needed cranking power. All Delco heavy-duty Freedom batteries can be placed in any of the RCCC recommended battery mounting locations. RCCC recommended practices 102, 103, 104, and 117 describe the recommended mounting locations to obtain minimum battery vibration. Battery testing is just as important with maintenance-free batteries as it is with lead antimony batteries. Let's now turn our attention to on-vehicle battery testing. When a cranking complaint exists, check for and fix any obvious defects, such as loose connections at the battery or at the cranking motor. Also, any batteries which have obvious physical damage should be replaced. Next, inspect the built-in hydrometers. Use a light if necessary. Unless the batteries were run down by repeated cranking, any green dot appearance means the battery has sufficient charge for testing. A dark indicator means the battery must be charged before testing it. If the batteries are still in the vehicle, connect the charger directly to the steel nuts holding the cable termination in place. This method will charge all batteries connected in parallel. This means that if there are 4 batteries in parallel, the total current shown on the charger is divided among the 4 batteries, and charging times of several hours may be required before obtaining the green dot. Batteries that are out of the vehicle or that have the cables removed may be charged by connecting charger to the lead pad or the AC Delco ST1201 adapter installed over the studs. Charge the batteries until the green dot appears. Refer to Delco Remy Service Bulletin 1B116 for the safety precautions involving the charging of batteries. Once the batteries have achieved the green dot condition, they are ready to be tested. Batteries which are connected in parallel must be disconnected before testing. Remove all negative cable terminations first on negative ground systems, or first remove all positive cable terminations on positive ground systems. Then disconnect the other terminations. To facilitate the load test, install either an AC Delco adapter ST1201 or a stainless steel nut AC Delco 7802 from the sealed cable as shown. Connect the battery load tester directly to the adapter or under the nut as shown. The tester's alligator clips must contact the lead pad. Batteries which received a boost charge cannot be immediately load tested, as the surface charge which results from charging must first be removed by applying a heavy current draw to the battery. To remove the surface charge, adjust the load control to obtain 300 amperes. Turn the load off after approximately 15 seconds and wait 15 seconds before proceeding. If the battery being tested is a Delco 1200, the specified load is 235 amperes. For the Delco 1110, the specified load is 310 amperes. The load can be determined by taking 1/2 of the cold cranking rating. This information can also be found in Delco Remy Test Specifications Bulletin 1B188. With the voltmeter of the battery load tester also connected, apply 235 ampere load for 15 seconds. Read the voltage while under the load at 15 seconds. Estimate the temperature by determining to what temperature the battery was exposed over the past several hours. If the voltage was less than the minimum voltage for the nearest estimated electrolyte temperature specified in Bulletin 1B188, the battery is defective or worn out. If any of the preceding steps were omitted or not fully performed, a battery might be condemned only because it was too discharged to pass the test. Over 50% of the batteries that fail to perform are simply discharged. Proper recharging and testing would have returned them to service. After each battery has been tested and defective batteries replaced, reconnect the cables in the reverse order than the way they were removed. That is, first the hot sides, then the grounded terminations next. Be sure the hold-down brackets are securely installed and that all cables are secure and not pinched. It's a good practice to check both the cranking voltage and the charging voltage to assure all electrical systems are functioning properly. Replace the battery box covers when applicable. To summarize the test procedure: 1. Perform a visual inspection. 2. Observe the hydrometer to determine if the battery is charged enough to test. 3. Remove the surface charge and apply specified load for the test. By following these test procedures, you will not only detect defective batteries, but you will also retain all good batteries. Some conditions that can cause poor cranking performance, even though the batteries pass the test procedure, will now be discussed. First, is the total capacity in cold cranking amperes of the batteries the same as or greater than that recommended by the vehicle manufacturer? Batteries in series will have the same cold cranking ampere capacity as a single battery, whereas batteries in parallel will provide additional ampere capacity. In other words, parallel battery capacities add. The same is true for the reserve capacity of the batteries. Applications that have high electrical loads, such as extra lights, electric winches, etc., may require additional batteries in parallel or a higher output alternator at idle to prevent cycling. If the cycling condition cannot be corrected, the high-cycle Delco 1150 battery should be used. When in service, if the Freedom batteries have sealed cables, except for an occasional tightening of the alternator belt and battery connections, no periodic maintenance is required. If open eyelet terminations are used, regular removal and wire brushing of the terminals is required. Some corrosion will appear due to moisture and accumulation of road dirt. Additional information on battery testing, charging, jump starting, etc., are covered in Delco Remy Service Bulletin 1B116. The heavy-duty Delco Freedom batteries 1200, 1110, and 1150 have been designed to provide durability and long life never before possible. For additional information on these batteries, please contact Delco Remy Division, Publications Section, Service Development and Training, Anderson, Indiana.